Preparing for integration developer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does an integration developer do, and what makes a good integration reliable? An integration developer connects systems so data and processes move reliably between them. I focus on APIs, events, files, and middleware, but the real job is contract design, error handling, security, and observability. For example, syncing orders from an e-commerce platform to ERP needs mapping, retries, duplicate protection, and reconciliation. Good integration work is not just connecting APIs, it is making the flow predictable under failure. While answering, focus on the integration developer's purpose, common integration patterns, middleware, APIs, data mapping, error handling, security, monitoring, and why reliability matters more than simply connecting two systems. Question 2. How would you explain the difference between REST and SOAP in an integration project? REST is resource-oriented and usually uses HTTP verbs with JSON, so it is lightweight and easy for web and mobile clients. SOAP is protocol-driven, often XML-based, and commonly uses WSDL contracts, WS security, and stricter schemas. I choose REST for simple, scalable service integration. I consider SOAP when an enterprise partner needs formal contracts, transactional standards, or legacy interoperability. The best answer is not which is better, but which fits the integration contract. Make sure to cover REST and SOAP fundamentals, payload formats, contracts, security options, enterprise use cases, interoperability, performance trade-offs, and how you decide based on partner requirements rather than preference. Question 3. How would you design an integration between a CRM system and a billing platform? For a CRM to billing integration, I start by defining source of truth, customer identity, account status, pricing, and invoice ownership. Then I design contracts for create, update, and cancellation events. I prefer event-driven sync for changes and scheduled reconciliation for safety. I add idempotency keys, dead letter handling, field mapping, and monitoring. The goal is not real-time at any cost. It is accurate billing with traceable failures. In your answer, talk about source of truth, data ownership, event flow, APIs or queues, mapping idempotency, reconciliation, monitoring, and how you handle failures without corrupting customer or billing data. Question 4. What is idempotency and why is it critical in integrations? Idempotency means the same request can be processed multiple times with the same final result. In integrations, retries are normal because networks fail after a request reaches the target. I typically send an idempotency key, store process transaction IDs, and make updates deterministic. For example, creating an order should not create two invoices if the client retries. Idempotency is one of the best protections against duplicate messages and partial failures. Be sure to mention retry scenarios, duplicate message risks, idempotency keys, transaction identifiers, deterministic updates, safe create operations, and why idempotency is essential in unreliable networks and distributed systems. Question 5. How do you handle errors, retries, and failed messages in an integration flow? I treat errors as expected behavior, not exceptions to ignore. Transient errors, like timeouts or 503s, get retries with exponential backoff and jitter. Permanent errors, like validation failures, go to a dead letter queue or workbench with useful context. I use circuit breakers to stop hammering unhealthy dependencies and alerts for failure rate spikes. The key is separating retriable from non-retriable failures so recovery does not create more damage. While answering, cover transient versus permanent errors, retry policies, exponential backoff, jitter, circuit breakers, dead letter queues, alerting, and the danger of blindly retrying validation or business rule failures. Question 6. When would you use synchronous integration versus asynchronous messaging? Synchronous integration is best when the caller needs an immediate answer, such as validating a tax ID during checkout. Asynchronous messaging is better when work can continue independently, like sending fulfillment requests or updating analytics. Queues absorb traffic spikes, decouple systems, and improve resilience. The trade-off is eventual consistency and more operational complexity. In interviews, I explain the business SLA first, then choose sync or async based on latency and reliability. Make sure to compare latency, coupling, reliability, user experience, queues, events, SLAs, eventual consistency, and practical examples where synchronous API calls or asynchronous messaging are the better choice. Question 7. How do you secure APIs used in system-to-system integrations? For API security, I prefer OAuth 2.0 when a client needs delegated access, and client credentials for system-to-system calls. Tokens should be short-lived, scoped, and validated on every request. I also use TLS, secrets management, request signing for sensitive partners, and IP allow listing when required. Authorization matters as much as authentication. A valid token should still only access the resources and operations its scope permits. In your answer, discuss OAuth flows, client credentials, JWT or opaque tokens, scopes, TLS, secrets management, token expiry, request signing, and the difference between authentication and authorization. Question 8. How do you approach data mapping and transformation between two systems? Mapping starts with understanding semantics, not just field names. Customer ID in one system may mean account, contact, or billing entity in another. I document canonical models, transformation rules, default values, enum mappings, time zone handling, and validation constraints. For complex flows, I keep transformations testable and versioned. A good mapping design prevents silent data corruption, which is often more expensive than an integration that fails loudly. Be sure to mention semantic mapping, canonical models, transformations, validation, enum and time zone handling, schema evolution, testing, documentation, and preventing silent data corruption across systems with different meanings. Question 9. What are webhooks, and how would you design a reliable webhook receiver? Webhooks are push-based notifications from one system to another. I design them assuming delivery can fail, arrive late, or be duplicated. The receiver should verify signatures, respond quickly, persist the event, and process asynchronously. I use event IDs for deduplication and replay support for missed events. If ordering matters, I add sequence numbers or fetch current state from the source system before applying changes safely. While answering, focus on webhook delivery guarantees, signature verification, fast acknowledgements, asynchronous processing, duplicate events, ordering, replay mechanisms, idempotency, and how receivers recover from missed notifications. Question 10. How do you manage API versioning without breaking existing integrations? API versioning protects consumers from breaking changes. I treat adding optional fields as backward compatible, but renaming fields, changing meanings, or tightening validation as breaking. Versions can live in the URL, header, or media type. The important part is a clear deprecation policy. I publish contracts, change logs, and migration timelines. In integration work, surprise changes break production, so compatibility and communication are part of the design. Make sure to cover backward compatibility, breaking versus non-breaking changes, version placement, deprecation timelines, contract documentation, consumer communication, and how versioning reduces production risk and integrations. Question 11. How would you handle rate limits when integrating with a third-party API? When a partner enforces rate limits, I design the client to be polite and predictable. That means reading limit headers, throttling requests, batching where possible, and using backoff on 429 responses. I also prioritize critical traffic over bulk sync jobs. For high volume, I use queues and worker concurrency controls. Rate limits are not just errors to retry. They are capacity contracts with the provider. In your answer, discuss provider limits, 429 handling, throttling, batching, backoff, queues, concurrency control, traffic prioritization, and designing clients that respect capacity contracts instead of overwhelming partners. Question 12. How do you handle data consistency when one business transaction spans multiple systems? In distributed integrations, I avoid assuming every system can commit in one transaction. Instead of two-phase commit, I often use saga patterns, compensation actions, and reconciliation jobs. For example, if payment succeeds but order creation fails, the system should either retry order creation or refund payment. I make states explicit: pending, completed, failed, compensating. This gives teams operational visibility and a safe path to recover from partial success. Be sure to mention distributed transaction limits, eventual consistency, saga patterns, compensating actions, state transitions, reconciliation jobs, partial failure recovery, and why two-phase commit is often avoided. Question 13. What monitoring and observability would you add to an integration platform? Observability tells me whether the integration is healthy and where it is failing. I track latency, throughput, error rates, retry counts, queue depth, dead letter volume, and business metrics like orders synced. Correlation IDs are essential across systems because logs otherwise become fragments. I also build dashboards and alerts around symptoms, not noise. A technically successful API call still fails the business if the wrong records are synced. While answering, cover logs, metrics, traces, correlation IDs, dashboards, alert thresholds, queue and dead letter monitoring, business-level metrics, and how observability speeds troubleshooting across multiple systems. Question 14. How do you design and operate file-based integrations such as SFTP batch feeds? File integrations are still common for banks, ERPs, and legacy partners. I handle them with secure transport like SFTP, encryption, strict naming conventions, checksums, and schema validation. Processing should be atomic. Receive, validate, archive, process, and report status. I also design for duplicate files and partial transfers. Compared with APIs, files are simpler for batch exchange, but weaker for real-time feedback and fine-grained error handling. Make sure to discuss SFTP, encryption, checksums, file naming, atomic processing, schema validation, archiving, duplicate detection, status reporting, and why batch files still matter in enterprise integration. Question 15. A production integration suddenly starts failing. How would you troubleshoot it? I start with impact. Which business process, how many records, and whether data loss is possible. Then I trace one failed transaction using correlation IDs across source, middleware, and target systems. I check recent deployments, partner incidents, auth expiry, schema changes, rate limits, and queue backlogs. After containment, I replay or reconcile safely. The final step is prevention, better alerts, stronger contracts, or automated validation. In your answer, talk through impact assessment, transaction tracing, correlation IDs, recent changes, authentication issues, schema mismatches, rate limits, replay strategy, reconciliation, and post-incident prevention. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.